We have two samples of the radioactive polonium here. So you have like sample 1 and sample 2, and it's told to you, right, that after 69.2 days, number of polonium in the first sample is twice that of the second sample. So this is like after 69.2 days, right, you have twice the number of samples, okay, in the first one compared to the second one. So which of the statement is true? Okay, so let's look at option A. After 69.2 days, right, is it true that 1/4 of the initial amount have decayed to the lead? Well, you can look at the formula, right? N equals to n naught half to the power of t upon t half. Okay, so this is for option A. So if you have only 69.2 days have passed, and this is like half the half-life, right? Half the t half. So the n over n naught, right, will be equals to half to the power of 0.5. Half to the power of 0.5, right, is not equals to 1/4. This is actually 1 over square root 2. Yeah, so it's actually, right, 70% of the particles, right, remain. So which means, right, 30% have decayed. Okay, so A is wrong. What about for B? After 69.2 days, the chance in any one polonium atom will decay in the first sample is twice that of the second. Well, this is definitely wrong, because, right, let's understand what does it mean by the chance for any atom to decay. This is simply talking about the lambda. Because lambda, right, which is the decay constant, is talking about the probability that any particular random nuclei will decay in the next 1 second. Okay, so this lambda, right, is invariant to the n, is invariant to anything. It is fundamental and basic, right, and unique to the particular nuclide. So since we are talking about the same polonium in both cases, they have the same lambda. Okay, so this lambda is not affected by the number of nuclei left in the sample. So this is also wrong. Third one, initial amount of polonium in the first sample, right, is twice that of the second. Is that true? So just now we draw this diagram, right? This at some time is 69.2 days. So about t equals 0. Okay, so in this same sample, right, we should have expected, right, the double. Okay, because, right, whatever this is, okay, when it dropped to here, 30% decay. Same for the other guy. Okay, also 30% have decayed. So if you compare, right, the beginning, so here is 2 times the other one. Therefore, right, at the beginning, this is also 2 times. Yeah, because they share the same half to the power of 0.5. Okay, so C is actually the true one. Let's continue and look at D. Rate of increase of lead, right, is proportional to amount of lead present. That's actually false, because, right, the rate of increase of the lead is actually the dN of the lead, right, over dt. This is simply the activity, right? The activity, right, is actually equals to proportional to n, and this n is what? N is the n of the polonium, not lead. So the rate of increase of the lead, which is the one polonium turned into, is proportional to the amount of polonium present, not lead present. Okay, so this is actually PO. So this is false.